So this is the first problem of today's Div 2. And in this problem, we're given that define the distance between two permutations A and B, each of length n as the minimum value of AI minus BI, absolute value of this for all I between 1 to n. We need to find a pair of permutations of length n which have maximum possible distance among all pairs of permutation of length n. So then we are given what a permutation and what is absolute value. So I hope this thing is known to everyone. So how do we approach this problem? First of all, do you think this is a greedy problem?
No.
Yes, no, what?
No.
Yes, why no? Why this isn't a greedy problem?
Sir, because there is a observation of pattern, or we can say constructive algorithms.
Yes, exactly. See, okay, let me complete this point. This isn't a greedy problem because you'll start from greedy, but soon you'll realize that it will lead, like if you want the optimal result, it will lead you to a point where the solution is fixed and it's an observation. So you can say that yes, it is a kind of like greedy, but you'll start from greedy. And the thing is, it will help you. Like, what is a greedy? Greedy is like you'll try to first maximize, and then you'll realize that yes, this is there's a pattern being followed. So then it will lead you to a observation. Is it making sense? Like, what is a greedy problem? Like, greedy is like priorly at the initial point only you decide that okay, this is the best way that you can have to an arrangement, and then without changing it, you'll go forward. Like once you decide for the first index, then for the second index, and you won't change your earlier indices once you go beyond a point. Is it making sense? No.
Sir, but the question was that some observations are very random. So
Yes.
suppose how to cope up with them. मतलब अगर वो लग गया तो लग गया, नहीं तो नहीं लगा तो.
लाइक नहीं मतलब ऐसा है कि मतलब जब तुम कुछ सोच रहे हो तो अगर ऑप्टिमल डायरेक्शन सोच रहे हो तो ऑफ कोर्स ऐसा तो होगा कि तुमने एक सोचा एंड वो इनिशियली यू थॉट दैट ओके दिस इज द बेस्ट वे, बट इफ देयर इज अनदर possibility is giving you a better result, like you are able to get the a better value. So of course greedy ही तो होता है कि your initial like uh, your previous criteria wasn't correct. Is it making sense?
Yes, sir.
Okay. So now tell me how to solve this. Like, other if you're finding the difference between AI minus BI, so at ith index, which two terms matter? At ith index, only AI and BI matter, nothing, no other terms matter. Why? Because at ith index, the value that will be contributed, like that will finally matter is AI minus BI. So now let's like if you have two permutations, so instead of randomly having two, both of them randomly, let's try to fix one. Because if you even if you fix one, then also the AI minus B combination should be completely it will cover everything if you are able to just change B, permutation B. Is this thing making sense to everyone? So let's say we have this 1 to n permutation fixed, and what we are trying to we have to find what is the minimum value of AI minus BI, and we need to find a pair of permutations of length n which have maximum possible distance among all pairs of permutation. So how to find the maximum possible distance among all pair, like how to find this if we have, let's say if we have fixed 1 to n. See, if n is even, then n by 2, okay, let me write it here. I think this was not visible up till now. Is the writing screen now visible? Okay. So, like I was saying that if we have fixed 1 to n, if we have fixed 1, 2, all the way up till n, so this is my A, and now what can be my B? Like B can be anything, doesn't matter. And I want the maximum, like the minimum of my AI minus BI to be maximum, right? Yes, no? Like this is, in short, the problem statement is this only. So there are two guesses. If n is even and n is odd, what will you do in case of even and what will you do in case of odd? If n is odd, then basically n by 2 seal. Now this value can be attained in a difference of n by 2, and for even we can get a difference of n by 2, like which, when will this happen? When n will be paired with n by 2, like you can just subtract from, like whatever you are pairing with x, subtract x minus n by 2 and pair it with this, and if this value turns out to be less than 0, then pair it with x plus n by 2. Similarly here for odd also. Is this making sense? So here you'll get the absolute difference of at least n by 2. Is it making sense? Like this is the only observation that he needed to for this problem. So like, is everyone able to understand like how I'm pairing? Like anyone having any doubt? Otherwise, like after this, there's just the solution. So like what you can do, just like I said, A can be just 1 to n. Now for B, you can just do, for every element like here, just add n by 2. If this thing turns out to be more than n, then do x is basically AI. If this turns out to be more than n, do AI minus n by 2. Is it clear? Yes, no? There are other ways also, but I like, there is no point in discussing those, but there are other ways also. You can do something once you have filled from 1 to n, fill this with 1 to n by 2, and this with n by 2 plus 1 to n. Like same thing as this. Is it clear? So now how, like initially we, this is not exactly a greedy set, like this is a constructive only. But if you look at this, like you started from this point that you need this to be maximum. And clearly, like this is not like you don't need any algorithm, you don't need any programming basics for this problem. This is just an ad hoc problem that is a simple constructive plus an observation problem. Is it clear? Okay, now, like I said, if you want what is the logic behind this? The logic is simply that we start with a greedy point of view, that we need to maximize the minimum value of AI minus BI. That is what I said at the start. This is not actually a greedy, but you started from this only, right? Once you fix this, like let's say you'll try to like 1 to n is fixed, and now you are trying to find b1. So whatever you need to keep, like you need to keep in mind 1 minus b1 should be more than the value that more than or equals to the value that you're trying to achieve. So this was the logic. So first I tried to achieve, let's say, can I get any random value n by 3 or n by 2? So if I'm trying to get the n by 2, what should be this? Can I fix each of these such that I'll get every value more than equals to n by 2 difference? So this is the logic. Is it clear? Any other doubts? Okay, so let's
Sir,
go
but
back. Yes.
one doubt was there, sir, how to approach such problems which are strictly observation based?
Yes. So see, observation problems, these like you can solve like if there's a binary search problem, or let's say there is some problem that requires uh, binary lifting or maybe segmentaries. Those are, if you have solved enough problems, like let's say 50 problems, or at least let's say 20 problems, like then you can think in those directions. But observation problems simply, like first of all, you should have solved like at least, like I would say 70, 80 or 100 problems of observation problems. Like they,
Means it is only practice based.
yes, the first of all, they are practice based. Second, it really depends whether you are thinking clearly or not. Like sometimes I also stuck at observation problems in like when I'm giving, like I usually give many of these virtual contests, and during the contest I'm focused, but usually what happens during virtual contest I'm not that much focused. So I also struggle at those, like I really invest too much time in problems B sometimes. Why? Because B is usually an observation problem, and I'm trying to write something, but I'm not clearly thinking. So I'm just writing something in the paper. But you, like, I'm not actually getting to anywhere near the solution. So this thing is also there. Observation problems, for observation problems, you have to think in right direction. See, usually what happens, you just need 3 lines. Like if you're writing on a piece of paper, if you correctly are able to deduct 3 things, you will get the solution. But the thing is, you are just going back and forth in between these two. You come here, go back. So this is like this habit will be developed from practicing, and also like I would suggest that you also like try to give virtual contests. Like I always say this, that try to give virtual contests. Like it's like it will really help you managing time and like these problems. Like you'll already know, once you read the problem statement, you'll already know that what is required if you have like enough practice. And that practice is different than like upsolving. Upsolving helps you to learn new things. Virtual contest helps you that the things that you already know, how to implement those in a given time limit and
Sir,
how to solve into
what exactly virtual contest mean?
virtual contest. Like in code forces, you can give any contest, and it will be under a time, and you can see your ranks also.
Okay, sir. Thank
So let's go to the next problem. So the next problem is define f of x as the largest divisor of x other than x itself. For example, f of 12 is 6, f of 7 is 1. Like the number that is the biggest number that which divides x other than itself. So now, given an integer k, we need to find the sum of all n such that this k is the highest divisor for n other than n. And if n is between, if k is between 2 and 10 to the power 6, it can be proven that the answer will not exceed 10 to the power 18. It's quite obvious, but I'll explain this also why it's obvious. So now for each we are given k, and we need to find the sum of all of these n for which f of n is k. Now, first of all, my question is, what is this problem? Like, what do you think? It's
Greedy.
okay. Why? Like, it's also like it's greedy, okay, but it's also an observation problem. If you look at it, like, first of all, like, why observation? See, first of all, what is f of n? Yeah, the correct thing is it's a number theory problem, by the way. But okay, like first of all, what do you need to observe? You need to observe that f of n. Like f of n is what? Like usually what a number can be written by n divided, like x is the divisor, n by d, right? So f of n is the biggest divisor, right? The biggest d. Yes, no, this thing where d is not equals to n. So d must be something like n into some alpha. Yes, no, and alpha shouldn't be equals to 1.
Yes.
So n will itself, like, if like, what is the lowest form of n that you can break n into? What is the lowest form of n that you can break it into? You can break it into its prime factors, not smaller than that. Why prime factors? Why cannot you break n into smaller than its prime factors? Because prime factors cannot be broken further. If you are given 12, you can write this as 2 into 2 into 3. You cannot break this further down. Why? Because 2 cannot be broken down further, this 2 also, this 3 also. So n can be at max broken down as prime factors. And after of that, I need to find, okay, wait a second. I think I have n is equals to d into alpha. This is alpha, right? So like I said, n can be broken down as at max as its prime factors. So now I need something will be d, something will be alpha. D should be the biggest, so alpha should be the smallest, because d into alpha, let's say, is constant, it's n, right?
Sir, can you please repeat?
Like n can be broken down into its prime factors. Let's say you cannot break this down into further. If n is 12, you can write this down as 2 into 2 into 3, not smaller than this. If n is fixed and n can be written down as d into alpha, if d needs to be the biggest, alpha should be the smallest as possible. Yes.
Yes.
So what should be the alpha out of this? If this is 2 into 2 into 3 is n, what should be alpha? Or if let's say I have 2 into 2 into 3 into 5 into 7, this is
2
my
or
n.
3.
Why 2 or 3? Why 2 or 3? To take 2 here. If alpha is 2, d will be 6. If alpha is 3, d will be 4. So these two values are not same. So why 2 or 3? Only 2, right?
Only 2, sir.
So is everyone like clear up till now? Okay, any doubts? If not, we'll proceed further. So basically for 1 to n, 1 to n, if I ask you for any number, any random value n, you can find its its d as its d will be n divided by alpha. Alpha is the smallest prime factor.
N bar 2.
No, no, two, if let's say if two is not it's not always like two is the prime factor. I'm just saying that in case of 12 it's right, but for generic, in like if I ask you f of x, it is nothing but n divided by smallest prime factor of n. So if n is, let's say, 13, then smallest prime factor of n is 13 is 13 itself. So in that case, you'll get 1. If I give you 15, then smallest prime factor of 15 is 3. So you'll get d as 5.
Sir, sir, n never will be a prime number because 2 से बड़ा रहेगा ना k in the constraints.
Like, is it given in the problem statement?
Uh,
Okay. Yes, yes, yes. K. We okay. You are going if according to k. I'm just right now concerned about n. Let's forget about
हाँ,
k. You are looking at this value, right? This
yes,
is
yes.
k, and you're saying that this is more than 2, so this won't be prime. Okay, it's okay. But let's say I gave you a value of n, and then you have to find. Okay, like what will be k or f of x in that case? So now let's say you have this k and you wanted to apply brute force. How would you solve this? How would you have solved this?
Take all prime factors and then
No, no, no. First of all, what should be like how what can be the maximum n? First of all, I want to know this.
n by 2. Sorry,
No,
maximum.
no, maximum n. If k can, if this value can go up till 10 to the power 6, then what can be this value, maximum value? N can be up till maximum up till if you just have like a rough upper bound, it will be maximum up till k square, not n square, k square. Like n can go up till k square, but like try to understand this that f of x is n divided by alpha. Alpha is the smallest prime factor. Okay, so this can go up till 10 to the power 6. So let's say 10 to the power 6 minus 1 or 2 or 3. Let's say 10 to the power 6 minus 3 is the prime factor. I'm not saying it is, but there would be a prime factor very close to 10 to the power 6, right? So if you take that and multiply it, like take the square of it and take n as that. So for that, like let's say this is the prime and I take n as p into p. So for that n, you will get exactly this as your 10 to the power, like whatever p was as your biggest divisor. Yes, no, right? So that's why n can go up till 10 to the like 10 to the power 12. So one thing we cannot brute force from like we cannot go from 1 to n, like 1 to some range 10 to the power 12, and for every value just count like what is f of k, like how many, if what is the prime, like we can find SPF. Let's say this is the value I. I'm iterating through I. I'll find SPF of I and increase this, like whatever the count of this is increased. And finally, when I have to answer for any k, I can just print count of k. This would have worked, but I'll get TLE since I'm iterating from 1 to 10 to the power 12. Is this thing making sense? Like we have to optimize this only. What about others? Any doubt up till now? This would have worked, but the thing is, I'll get TLE. Now, is there anyone who knows like how to optimize this? Like how, Steve? Like I know, Steve, but like, can you be more specific?
I guess for even numbers, it's pretty obvious because even numbers have a factor of 2 in itself. And as we increase the value, for example, we want k to be the highest factor. So the answers will be k into 2, k into 3, somewhat that. For even numbers, we can only go up to k into 2. For k into 3, we can never go up to there.
Yes, yes. So let me explain this. Perfect. See, we want to do this, but we cannot do this. So let's try to approach it otherwise. So we'll do the exact same thing. We'll calculate the count only. So we'll try to calculate the count of k. We'll iterate through k from 1 to 10 to the power 6, and we'll calculate the count of k. And how to do this? For k, if k is even, n can be n. No. Sorry. If if k is your biggest divisor, what can be your n? What all values will be taken by your n?
K into 2, K into 3, K into 5. Sir, can you give example of K into 5 and K into 7?
Yes. So the thing is, k shouldn't have this. K shouldn't, like, if k is already having a 2, in that case, this won't be valid. Why? Like, k shouldn't
Because
have 2.
k 2 and 3 will give us 6.
Yes, because see, if let's say k is having something like 2 into 3 into 5. So 2 3 is a 6, 6 5 is a 30, 30 into 3 90. So for 90, 235, that is 30, is not the valid f of x, not a valid biggest divisor. Biggest divisor is 45. That is 2 will be taken out. So you should go till primes, till the smallest prime factor. Like, you shouldn't, like, this should be less than or equals to the smallest prime factor of k. Now somebody asked me, can I give a like example for 7? You can take anything, like k can be anything which is having a smallest prime factor of 7 and anything more than that, something like this. So now the solution is pretty simple. We'll iterate our k from 1 to 10 to the power 6. For every k, we'll maintain count of k. Count of k is nothing but how many numbers, for what all values of n, like sum of all the values of n, which are having k as their biggest divisor. For those values, what we need to do, we'll go to k into primes, and this primes will be from 2 to smallest prime factor of k. Is it clear? Okay. Like, what part is not clear? Like, I'll take doubts now. The count part.
Sir,
Like,
count part.
हाँ, तो ये जो count k है, count k is giving us sum of all values of n, sum of all values of n, which जिनके लिए k जो है वो बिगेस्ट फैक्टर है. तो अगर k उनके लिए बिगेस्ट फैक्टर है, मतलब उन n's के लिए k है बिगेस्ट फैक्टर, तो एक छोटा फैक्टर भी होगा अल्फा. अल्फा भी एक प्राइम फैक्टर होगा, क्योंकि अल्फा को ब्रेक नहीं कर सकते. अगर अल्फा को ब्रेक कर सकते तो k और बड़ा हो जाता, तो k स्मॉल बिगेस्ट वो नहीं है ना. तो n, उन सब n के लिए k बिगेस्ट फैक्टर है, तो अल्फा एक उनके लिए स्मॉलेस्ट एक प्राइम फैक्टर होगा. तो बेसिकली हमें बस ये करना है कि इस n का SPF जो होगा वो अल्फा होगा, स्मॉलेस्ट प्राइम फैक्टर. तो अब हमें ये करना है, अगर इस n का स्मॉलेस्ट प्राइम फैक्टर अल्फा है, तो इसका मतलब k में भी अल्फा या अल्फा से बड़े ही प्राइम फैक्टर्स होने चाहिए, इससे छोटे नहीं होने चाहिए, राइट? क्योंकि k इंटू अल्फा n है, और n का स्मॉलेस्ट प्राइम फैक्टर अल्फा होना चाहिए, और वो k में उससे छोटे फैक्टर्स नहीं होने चाहिए. तो हमें बस ये करना है, एक हम k के लिए काउंट निकाल रहे हैं कि कितने n हो सकते हैं. तो हम k n की क्या क्या पॉसिबिलिटीज है. n हो सकता है k इंटू प्राइम, अब ये वाला जो प्राइम है, लाइक हमने यहाँ पे देखा कि ये अल्फा जो है वो के में इससे छोटा नहीं होना चाहिए फैक्टर, तो इससे छोटा नहीं होना चाहिए, तो अल्फा के में क्या क्या पॉसिबिलिटीज है कि अल्फा इज मोर देन, नॉट मोर देन, अल्फा इज लेस देन और इक्वल्स टू द स्मॉलेस्ट प्राइम फैक्टर इन के। तो बस वही चीज है कि इस प्राइम की जो रेंज है वो है 2 इंटू स्मॉलेस्ट प्राइम फैक्टर ऑफ के, और के तो हमें पता ही है, हम के पे आइटरेट कर रहे हैं, तो बस इस इन प्राइम्स पे आइटरेट, के पे आइटरेट करके फर्दर इन प्राइम्स पे आइटरेट करके we'll count, find this thing and we'll add it to count of k, because ये जो n मिलेगा, ये जो n है, for that k is the biggest factor. Is it clear now? What about others? Like जिसने किसने पूछा था मुझसे डाउट? Is it clear to that person? हाँ. So if no one is having any doubt, we'll go ahead. Like why are others not replying? Okay. Enough, fair enough. Let's go ahead. Why isn't it SPFN? Why is, I have a doubt. Like somebody is asking me, like, can you explain it a little bit more? Like I didn't get it. And try to I have always said that don't like personally directly DM any doubt to me. Like you should ask your doubt like publicly, because it will help others also. Like the doubt is why isn't it SPF of n? Why is it? Because n में क्या है? n क्या है? n का n का जो स्मॉलेस्ट प्राइम फैक्टर है वो होगा अल्फा, k इंटू ये। अब जो ये अल्फा है, दिस अल्फा शुड बी लेस देन और इक्वल्स टू SPF of k. Why? If I think that this is your question, why of k, why of not n? Because अगर k के SPF of k से बड़ा है तो फिर तुम्हारा ये assumption ही गलत है, तो n का SPF अल्फा नहीं होगा, और ये होना जरूरी है क्योंकि हमने अज्यूम किया कि k इज द बिगेस्ट प्राइम फैक्टर ऑफ n, वरना k से कुछ बड़ा मिल जाएगा। इज इट क्लियर? Okay, now let's go to the next problem. So the next problem is this: there are n islands numbered from 1 to n. Initially, every pair of islands is connected by a bridge. Hence, there are a total of n into n minus 1 by 2 bridges. The importance of the ith island is AI, and Everrule lives on island 1 and enjoys visiting the other islands using bridges. The cost of discovering the bridge between islands I and J is AI into AJ, and Dominator has the power to destroy any destroying any number of bridges such that the sum of cost of destroying the bridge is at most C. Like if the cost of destroying a bridge is C, then Dominator can destroy that bridge. Now we need to find the minimum number of islands, including island 1, that Everrule can visit if Dominator destroys bridges optimally. So first of all, like what we are given that there are, let me share this screen. Let me first like explain the problem. So we are given that there are there are n islands, and initially every pair of these, let's say there were three, so every pair of these had a bridge. Every pair is connected by a bridge. Like, let me first go, like, complete the problem, like, explain the problem, then we'll discuss how to solve this, okay? And there are a total of n into n minus 1 by 2. Like, this is a simple arithmetic sum. Like, how many bridges will there be? For 3, it will be 3. For 4, it will be 4 into 3 by 2. That is 6. So, total number of bridges are these. Now, initially, Everrule is on island 1, and the cost for, like, destroying the bridge between island I and J is AI into AJ. So now Dominator has the power of destroying any number of bridges such that the sum of cost, like if let's say Dominator decides to destroy this bridge and this bridge. So this is 1, 2, 3. So the total cost will be A1 into A2 plus A1 into A3. So we need to find the minimum number of islands that Everrule can visit if Dominator destroys the bridges optimally. So now tell me how to solve this problem. Like, what, first of all, what is this? Like, what do you think is the requirement? Like, first of all, this is not, I won't consider this as a graph problem. And as far as binary search, I think binary search solution can be there, but like I have to think in that direction. I haven't solved this via binary search. Like, if you clearly think like this is a simple, like, I would say addition, like I would say sorting problem. Sorting or not, like summing up, and like what you have to do. First of all, let's try to act like Dominator. Like, we'll try to break the bridges in such a way that every rule cannot go to some of the islands. Now, in order to do that, like what should be the pattern that we follow? And disconnecting bridges greedily. Like, if you try to do this greedily, you'll get TLE. So can you explain how did you approach this greedily? And first of all, I'm not even like sure how like greedily you will approach. Like, you don't know actually at the start of the like, if you're at a vertex, you don't know whether it's optimal to delete some edge or not. Like, if it's connected by n other vertices, how will you like delete it greedily? Okay, like, I'm not sure whether it would work like that or not, but you will just not cost. Like, were you getting TLE? Okay, okay, no, wrong answer. See, first of all, n square solution should pass for this. So let's try to come up with an n square solution only. See, instead of trying to delete edges, let's say this is my kind of graph and it is like the graph is completely fully connected. So I'm not going to draw each and every edge, but you get the idea. I think there will be, are there more edges? Have I left any edge? So maybe there will be more edges. So instead of like what you're trying to do, you're trying to delete edges like this. Instead of doing this, why not say that, okay, I'm not like this is different and this is different. You start from one. You start from one. Or even like we can say that, okay, this is different, this part is different, this part is different. So these can be connected. So if I say that, okay, I have divided my graph into two parts, there shouldn't be any edge from first part to second part. Then I can confine ever rule in the first part only. Is this thing making sense? What about others? Like instead of deleting the edges, I'm dividing my graph into two parts. Now, no, I'm not building the edges. Like, why do you have to build the edges? If there are n into n minus one edges present initially. I'm not doing anything with the edges. I'm just saying divide the graph into two parts. The part which has one will be visited by ever rule. The second part shouldn't be visited by ever rule. So there should be no edge from first part to second part. And other than those, you don't have to delete any edge in this part. You don't have to delete any edge in this part. Only the edges that were going between these two should be deleted. So do we know what is the cost for doing this? Can we find the cost? Yes, no. Is this thing making sense? Now, can we find the cost or not? If I give you this kind of arrangement that, okay, these are the two parts. If I give you the two parts, then can you find the, just give me a second. Yep. So I was here. So how to find the cost of such thing that if we have two islands and none of the islands is connected to like we have two parts and the islands belonging to the first part are not connected to islands in the second part. How to find the cost? So the cost can simply be found as for all the islands in the first part. Let's call these as AIs and these as AJs. So we just need to, for every island belonging in I, multiply it with every island belonging in AJ. Yes, no? This is your cost for destroying the bridges, right? Yes, no. Okay. So now the observation, like what is the observation that we need after this point? If AI into AJ is like the sum of these two is the total cost. And first of all, forget about observation. Like what is the brute force solution? After this point, if you have to solve this, what is the brute force that is that if you are required, what is the like how will you implement the brute force? So what you'll do, you'll try for every combination of subsets. Like you have a set from 1 to n of nodes. You'll try every combination of the try to divide these. And from those, you'll try to find the cost. And from that cost, if that cost is less than C, then you'll say that, okay, how many nodes are not visited? And from all of those cases, you'll get the maximum. Is it making sense? Okay. So now tell me, is this can we solve this problem if n is 100? Can we find every subset? No. Why? Because every potential subset, there are how many subsets? There are 2 to the power n subsets, right? Yes. So, sorry, I was saying that finding the total cost is AI into AJ, and we know that this is the total cost, right? And we know that if this is less than C, we know that this is one of the ways in which we can divide this. But now tell me if from this we are able to find that, okay, we get all the options that for which we have the optional ways, for all the scenarios, we find that, okay, we are able to skip 3, 4, 2 vertices, 1 vertices. But the total number of ways of these is how many ways there are to divide the subset of size n. So there are 2 to the power n ways. So that's why it's not possible. Is anyone having doubt up till now? So now 2 to the power n will clearly not pass because 2 to the power 100 is way more than, it will take way more than 10 to the power 9 operations or 10 to the power 7 operations that can be adjusted in a second. So now tell me how to optimize this. We'll do this only, but how to do this in an optimized way. Like 2 to the power n ways to 2 to the power n ways is simply not dividing in 2, but it's just an upper bound. 2 to the power n. Okay, sorry, I think I have under explained here. 2 to the power n is total number of ways to decide whether this will be selected, to find not just two subsets, but all the subsets, 2 to the power n. So in order to find just two subsets, what you can do, you can just find that from one, whether you'll include a vertex or not, whether you include an edge or not. So that will also be exponential only, not linear. But 2 to the power n is not dividing into 2. I hope this is clear. 2 to the power n is simply whether this edge is included or not, this edge is included or not. Simply finding all the subsets. All possible, yes. So now tell me how to optimize this. You have to be more interactive, like I said at the start. Anything that is coming to your mind, you just have to optimize this thing. Is there any observation? Okay, let's try to fix something. Let's try to say that, okay, the size of this component is fixed. The size of component in which every rule will reach every vertex. The size of this is fixed. Now, what can you say about these? Like these won't be reached, right? So the size of this will be n minus k. Yes, no. And now how will you, like, if let's say k is fixed, then like greedy is right, but how will you greedily decide which edges to break? Let's say your component size is k, like you have two components, which less cost? You have to find a, like the sum of these. Sum of this is, let's say, AIs. Sum of this is AJs. So let's say this is SI and this is SJ. Sum of second component. So eventually the cost will be SI into SJ, right? And if this cost is less than C, it's possible to have a component of size K in which every rule will visit every vertex, every island, otherwise not, right? Now tell me how to work with this. Like, let's say I have decided that, okay, K is the size. How to get SI and SJ? And one thing that you should keep in mind that at the start, like I said, this problem can be solved in n square. Where is it? Here I told, right? N is 10 to the power 6, 10 to the power 2. So instead of solving this in linear, try to think in something, or like you'll iterate from 1 to n, k. Like k is the size of your island. Now you need to decide for any value, you need to decide in big O of n that whether what is the value of Si into Sj. How will you do that? Take a minute. If you're able to like think in that direction, it's okay. Otherwise, I'll tell you. You don't have to do it in constant time. Do it in linear time. See, I think the answer is already present in the chat, but see, if this is your array A and you have K, K is fixed, like let's say 4. So you'll be forming, you need 4 vertices for which they will be broken from all the others. So which 4 vertices should you choose? Like what you'll do, you'll take the sum of these 4 and multiply with the remaining sum, right? Yes, no? So what should you take? You can take the smaller ones. And now, by the ways, even if you take the bigger ones, largest ones, it would not make actually any difference. Can someone tell me why? Even if you take the bigger ones. Because for k is equals to 4, this is the scenario. You took these. For k is equals to 4, you can take the smaller ones, these or these ones. If you take the bigger ones, this is same as the earlier case when k equals to 3 if you are taking for smaller ones. So for k equals to 3, smaller k, you are taking smaller, or k is equals to 4, you are taking bigger, are same. And your k will be going from 1 to n. So you can either take the bigger ones or the smaller ones. Right? And eventually you are multiplying both. So the values that you'll get, like over for all the values from 1 to k, the set of values will be same. Is this thing making sense or not? Otherwise, I'll explain this again. Why it doesn't actually matter if you take the smaller or the bigger. Like the smaller 3 values or the bigger 3 values, smaller k values or the bigger k values. Is it clear? So what you have to do, you just need to iterate your k from 1 to n, sort your array, take the bigger k values or the smaller k values, multiply them with the remaining, and from this, let's call this as Si, let's call this as Sj, find what is Si into Sj. If this value turns out to be less than C, you can have these k islands visited or these n minus k islands not visited, right? So accordingly, decide. Is it clear? Like the maximum number of islands that cannot be visited is your answer. Is it clear? What about others? Okay, so let's go to the next problem. So in the next problem, we are given that we call a permutation P of length n as k sortable if it is possible to sort the permutation in non-decreasing order using the following operation at most once. Choose a subset of indices from 1 to n and then add k to the elements present at most one indices in P. At all those present, at not one index, but at all those present in P. So finally, given n and a permutation P of length n, find the sum of all k where k is between 1 to n and P is k sort V. Okay, somebody had a doubt regarding the third test case. Yes, for the previous problem, of course, node 1 should be part of the first case. That is the k nodes that you are including to be gone through every rule. This thing. Like your first node should be part of this. So it should be not included in this thing. Always. And for the second thing, like let's like you can right now, like we have already started with the second, like the next problem. If you are able to come up like at this, able to understand yourself, then it's okay. Otherwise, I'll take it at the last and try to like ask questions at that point only when I'm like asking after discussing. Okay, so coming to this problem, we have k sortable is given a permutation of size 1 to n. Take any, there's a permutation, select any subset of size anything, like any subset, and add, you can add k to it. Subset of indices, like this is from, like these are the indices. So let me give an example. Like let's say permutation was 2 1. So if you choose your subset as 2, like this as your subset, then and you add k to the second position, that is, let's say your k was anything like k was 1. So then your array would become 2 2. Or if your k was 2, then your array would become 2 3. So both k equals to 1 and k equals to 2 are, for this it is k sortable. Is it making sense? Like, is the problem statement clear? Like, what is k sortable? Or is anyone having any doubt regarding what is like what do you mean by k-sortable? Whether a permutation is k-sortable or not? You just need to choose a subset of indices from 1 to n, and at all those indices, whatever elements are present, add k to those. After that, if the permutation is sorted, you're good to go. Otherwise, not. If like it's sorted, you will call the permutation as k sortable. Is it clear? So first of all, if we have to find now k sortable is clear, we need to find the sum of all k's for which the permutation p is k sortable. So we need to find sum of all of the k's for which the problem is like the permutation is k sortable. So tell me one thing. Can we first of all, can we find what is the minimum value that must be added? That must be added. Why? Like, for example, my permutation is 1, 3, 2, 6, 4, 5. So you look at this, it's more, it's like 1 smaller than the previous value, more, 2 smaller than the previous value, and this one is more. So if I look at this point, this should get at least 2 added. I'm not saying whether this is k sortable or not. This should be at least 2. You should add at least 2 added to this, right? Yes, no. So why 2? Because if you add less than 2, then this will never become more than this. Yes, no. So k equals to 1, like 1 sortable, this is never 1 sortable, this kind of thing. So, and like you just need to find like this, you can find the minimum value of k for which this can be k sortable. Is it making sense? Like just iterate through the array, find if this value is less than the previous value, how much less it is. So this will give you the minimum value of your k in k sortable. Is it making sense? And now let's like anything below this k doesn't work. Now let's try to find an upper bound also, such that after that point nothing will work. So how to do this? How to find the upper bound? First of all, see, you cannot add directly, like there's a point to at to which a value bigger can be added. Why? Like I gave you this example. Can someone think of any example? Let's say you have this, and this part is your increasing block. Okay, what do I mean by increasing? That all of these values are sorted in this. Is it making sense? Now, there are two things that if this is this increasing block, there are two things that I can say. One for the start, one for the end. What is it? this value should be less and this value should be less. Then only this is the maximum increasing block, right? Then only, because this condition is breaking at these 2 points. Yes, no. These are the two conditions, one from the start, one from the end. Yes, no. So first of all, this value should be increased. No matter what you do, this value should be increased. Yes, no. Second thing, this value shouldn't be increased, because see, I would be increasing all values by k only. This value should be increased, and this value, the last value in the block, should not be increased. Yes, no. Like there are these three things. This should be increased. I'll give an example also, don't worry. But try to understand just this thing. If there is this longest, biggest block, these two should be increased, this shouldn't be increased. If this is also increased, then no matter what, both are in both places, you are adding k. Is it making sense? This value shouldn't be increased. If this thing is clear, just write a yes. Otherwise, no. I'll explain this again. This key difference. Okay, this is not clear. See, if this is your increasing block, this means that at this point, this value was more than its next value. That's why otherwise, if this would have been like this, I would have drawn it like this. I would have included this also. But if I didn't include this, that means in this part, this is not like this, but it's like this. Similarly, it's not increasing after this point, it's decreasing. That's why I didn't include. So, okay, this part is not clear. So this means this value should be increased. I can only increase, I cannot decrease. I cannot decrease this value. I can only increase this, then so that this value becomes more than this. Similarly, I can increase this. I cannot decrease this, but I need to make sure that this is not increased. Why? Because I have at max one, I need to do at most one operation. I need to do at most one operation, subset of indices, not subarray. I'm not taking any subarray. I'm taking subset of indices can be this also, this index, subset of indices, not subarray. Subset of indices, like if you have a set 1, 3, 2, 7, like, or let's say 1 to n, you have a subset of 1 to n all the way up till n. 135 is a subset. 135 subset, not subarray. Is it clear? Like, I think you're getting confused. First of all, the problem is that choose a subset. And the second thing is, this thing is a increasing subarray, not a subset. This is the actual array which is increasing. And in this, you can say that this first value should be increased and the value which is after the last should be increased. But the last value shouldn't be increased, because you have at most one operation, and in that you'll be adding k. You are not adding different values. So if you choose both of these, if you increase both of these, both of them will increase by k. And eventually this will be this value will be more than this only. So that's why this shouldn't be increased. Is that clear now? So basically this means that you have to increase this. So you will increase this starting from here, either just increase this thing or increase this thing or increase this thing. And how much will you increase this? You'll increase this at least by whatever is the difference between these two. And try to increase all the way up till, like, whether you can go up till here. Why? Because you just need to check after increasing this shouldn't become more than this next value. If it's okay, just check with this. Like you're increasing up till here, whether whatever you increased, whatever the k, whatever you're increasing it with, if you increase this value also with this much, whether it's not exceeding, whether it's exceeding this value or not. If it's exceeding, it's okay. Otherwise, it's not okay. Now, the only thing is using this, we'll find the upper bound, like what is the maximum value, because after a point, if you increase this value too much, let's say you are adding 10 to the power 9 to this, you cannot adjust this value because this value is not getting increased. This will not increase. If you increase 10 to the power 9 this, you'll have to increase this also, because maybe this is getting more than this. So then you'll have to increase this also, this also. After a point, you cannot increase this. So using this, you can just find what is the value of k that can be added. So that will give you the upper bound. So now you have the lower bound, you have the upper bound, and every value in between will suffice. So our answer is nothing but, let's say, the number of digits in between upper minus lower is this thing. So our answer is d into d minus 1 by 2. D into d plus 1 by 2. Like the sum of everything between, like not this, like just find the sum of these digits. So everything between, so what will be the sum? Sum will be upper into upper plus 1 by 2, right? The sum of first two digits, sum of first three digits. So sum of first upper digits minus sum of first lower minus 1 digits, because lower at lower your value will suffice. So subtract lower into lower minus 1 by 2. Lower minus 1. Why lower minus 1? Because lower at lower the values will work. Lower bound. Is it clear? This is your answer. Is it clear? Yes, no. Yes, yes. Can you repeat lower plus 1, upper plus 1 and lower minus 1? Yes, I would repeat. So this thing is clear that we can get k sortable for every value k between, for every value of k between lower, more than lower, more than equals to lower, and less than equals to upper, right? Now our answer is lower plus lower plus 1 L plus 1. Let's call lower as L. So L plus 1 plus L plus 2 all the way up till U. So if I have to find the sum, what is upper into upper plus 1 by 2? The sum of first U digits. U into U plus 1 by 2. So this is the sum of 1 plus 2 all the way up till U. And now I need to decrease the part which is before this. So that is the part of which is sum of 1 to L minus 1. So sum of first n digits is n into n plus 1 by 2, n into n plus 1 by 2, right? So in this, replace your n with L minus 1. So you'll get L minus 1 into L by 2. So that's why this is the part that you have to remove. This is the part that you have to remove from this thing. Then you'll get the sum of this part. So, okay, this is clear. Any other thing? So then that's it. Thanks for joining. Bye-bye.